So from this example, what we will find out is the first thing you want to do is ask us to solve for node voltages and current I in the following cycle. So this is the current I, and then we have to solve for the node voltages. The first thing you want to do is to identify your node voltage. Okay, and before you can start identifying the node voltages, you identify the reference voltage first. So usually the reference voltage is the one with many branches. So what you will find out is that the reference voltage is going to be somewhere at the bottom. All right, so you can see here, you can pick these as our reference node. Okay, so the reference node is going to be the one with many branches. So you can see here we have our first node, our reference node here, all right, which is our ground node, by the way. We have also identified the node here, V1. We have identified another node here, V2. So this is node 1, it has voltage V1. This is node 2, we have node voltage V2. This is node 3. If you put everything here together, these two together here, you have node voltage V3. All right. So I think those are the basic nodes that we have connecting circuit elements together. At node 1, this is node 1. All right. So using node 1, you can go back and use the equation that we talked about. Using node 1, that equation we created. But to make life easy for you, I would prefer that we just use KCL to solve the problem. Okay, so this is 3S, this is conductance. Okay, so what you will find out at node 1 is what currents are going in, what currents are coming out of node 1. Current going into node 1 is 7 amperes, right? So you have -7, right, at this point. Also at this particular node, you have 5 ampere going out. So you have -7 plus 5. That gives you what? -2, right? So you have -7 plus 5, that gives you -2 current at this particular node. Like I said earlier on, the easiest way to deal with this is to just use your KCL to do it. The current passing through IS, it will just be, since the current is going from V1 to V2, it will just be V1 minus V2 multiplied by 1. Or divided by R1. R1 here, we are representing with conductance 1 over R1, that is G. So it's going to be V1 minus V2 multiplied by 1. Okay, if you expand that, it just becomes V1 minus V2. So this is the minus V2 here, and this is the plus V1 here. And you see 1 here, V1 minus V2 here. That's what is inside here. So if you do that, that's what you have. And also between 3S and this place, the voltage at this node will be, what is the voltage at this particular node? Can you see my cursor? 0, because it represents our ground node. Okay, ground voltage. It's going to be voltage at the ground node is going to be 0. So if you want to find the current passing this 3S, it will be equal to I equal to V over R. With our R here, we are using conductance, so it's going to be V times G. Okay, so this I will be V1 times 3. That is, this V1 times 3 is what you can see here. Can you see it here? This is the V1 times 3, and then this is V1 minus V2 here. If you just use simple KCL, all right? And then don't forget that we have 7 amperes and 5 amperes there, which we said the resultant will be -2 amperes. Okay, so this one minus this one minus 2 will be equal to 0 according to KCL. So -2, if you take it to the other side, it becomes +2, and then this becomes your equation 1. All right, and everything would be equal to 0. So you take it to the other side, it becomes +2. At node 1, this is node 1. What you want to pay attention to is the current entering a node, and then the current leaving a particular node. This is very, very important. So normally, what we should have is the current entering a node. We say it's going to be positive or negative.
Negative.
So you would have -7. Can you see that? This one is leaving the node. 5 ampere is leaving this node here. Is it going to be positive or negative? It's going to be positive. So you're going to have +5. We're going to have +5. Okay. Also, you notice that at this particular point, for this conductance 3 here, the current here will be I equal to V1 times 3, isn't it? Because there is 0, it will be V1 minus 0, so it becomes plus V1 minus 0 divided by, multiplied by 3, right? Because we are dealing with conductance, isn't it? Normally, if we were to be dealing with resistance, we divide it, so multiplied by, let's say this is our G1, so multiplied by G1. Do you follow that? And then if we continue for IS, because we're only dealing with this node, so we also have another IS here. So the current connect the voltage connected to this IS will be V1 and V2. So the current passing through IS will be plus V1 minus V2, all multiplied by G2, which is 1. Everything has to be equal to 0 according to KCL, because summation of all currents around a particular node is equal to 0. So if we try to expand all of these, you will end up with minus 7 plus 5 gives us minus 2. All right, V1 minus 0 multiplied by G1 will give us plus V1 G1, right? And then V2 minus 1 times 1, it gives us plus V2 minus V2. Everything would be equal to 0. Do you get? And then we had said that this is 1 is our G2, this is our G1. So you can say that our G1 is 3, so you are left with 3 V1. What's our V2? We don't know V2, so you have plus V2. This is supposed to be V1. Okay, so from 3 V1 plus V1 minus V2, this would be equal to 2. All right, this is the same thing as saying we have 3 plus 1. If you make V1, if you bring V1 out, because V1 is common to both of them, minus this is 1 times V2 equal to 2. So you can you see that the two equations are the same? So what happened here is that they just bypass all of these explanations. By the time you practice this over and over, you too would be able to just write these without having to write all of these. But if you can write them to avoid mistakes, I think it will be way better. All right. The same thing we're going to repeat for node 2. So now that we are here right now, what this simply means is that we can now go to node 2. Okay, let's find out what is going on at node 2. The same analysis at node 2. Okay, so this is node 2 here. So for node 2, what are the currents entering node 2? First of all, 5 is entering node 2, right? Isn't it? Can you see that? So if 5 is entering node 2, what polarity, what sign are we going to give to it? So we have minus 5 already entering node 2. And then you can see that node 2, we have 1 here, isn't it? As the conductance. So, and the current is going this way, is entering. So you have minus, right? And then if you have minus there, this gives you, so since we are dealing with node 2, it becomes V2 minus V1 multiplied by 1. Can you see that? Because this is conductance, this is V2, so it becomes the voltage across this will be from this node is our reference node that based on this explanation, this becomes V2 minus V1. All right. Also, we have dealt with everything coming in from this angle. Now from this side, now let's deal with everything from this other side here. For V2 with respect to 3s. Okay. So what do we have? This is 0, isn't it? The voltage here will be 0. So we have plus V2 minus 0, all multiplied by 3. And then we go on. What about what is happening to 2s here? The current passing through 2s from V2 to V3 becomes plus V2 minus V3 multiplied by what? By 2. If you add all of these together, this should be equal to 0. By the way, I think this is supposed to be plus, right?
Yeah.
This is supposed to be plus. Can you see that? Minus 5 plus V2 minus V1 plus 3. Is this 3V2 plus 2V2 and then minus 2V3 equal to 0. This is just mathematics though, so I don't need to bother myself. This is just addition and subtraction and expanding bracket and all of those. So you should all understand that. So if we continue, so you have V2 plus 3V2 plus 2V2. What would that give us? 6V2, right? Yeah, minus V1 is here already, right? So that's the only V1 we have. You have minus V1 plus 6V2. And then what you have here is minus 2V3, right? Equal to, if you take minus 5 to the other side, this would be equal to equal 5. Okay, so like I explained the other time, this is also the same thing as equation 2. Can you see that? Because this is minus v1. Minus 1 times v1 will give you minus v1. Can you see that? This is 2 plus 3 plus 1 is 6 v2. You can see we have 6 v2 here, minus 2 v3. You can see we have minus 2 v3 here, equal to 5. You can see this is equal to 5 here. So this is also the same thing. To find your v3. The easiest way to solve three simultaneous equations with three unknowns is to use the Cramer's rule. That's going to make life easy for you. You can also try to use the substitution method if you know what you're doing. Whatever it is you want to use it and use it well. Don't make any mistakes at all. I would recommend that you use Cramer's rule. It's one of the easiest concepts. This is 4v1 minus v2 equal to 2. Okay, that is why you have 4 here, by the way. So this is 2 plus 3 plus 1. This is 5v2. This is 6v2. And then this is minus 2. This is minus 1. And this is 2 plus 4 plus 1. This is another 6. Plus 4. This is 7. All right. And this is 17. So when you have that, I don't want to explain Cramer's rule to you guys, man. Okay. So you guys know how to fix that. It's simple and basic mathematics. Go check it out. If you have any problems with Cramer's rule, contact me personally. I'm going to try to explain to you. But I don't want to use this class to explain that. Is that okay? Because that's just simple mathematics. All right. So you use Cramer's rule, you find your delta first of all, you find your delta 1, you find your delta 2, you find your delta 3. V1 will be equal to delta 1 over delta, V2 will be equal to delta 2 over delta, V3 will be equal to delta 3 over delta. That's exactly what they're doing here. So what you can see here, this is delta 1 right up here. And for delta 1, it simply means this first column, you're going to replace it with your coefficients on this other side. Okay, so this is 2 here, this is 5, this is 7 here. So they replace everything here for V1 with this coefficient to find delta 1. So that delta 1 over this delta gives us our V1. The same thing for this. I said I won't explain this. Okay, let's just move on. Let's move on. All right. So they did all of those and then they found V1, they found V2. V1 is 1 volt, V2 is 2 volt, V3 is 3 volt. And you know our I, where is I? I will be equal to V2 minus V3. Can you see here? Because I is going to be V2 minus V3 multiplied by this G, which is 2 here. Because our I is in between this passing through 2s and is in between node 2 and node 3. So I will be V2 minus V3 multiplied by this G, which is 2 here. If you do that, you're going to obtain I to be minus 2 amperes. This is a very important question for you guys, and I encourage you to play with it as much as you can. Go through it as much as you can, understand it properly.